Hi, we're going to be working on mechanical waves and the speed of sound equation. This is the only math part of the wave section you'll need to know, so I want to go over it with you. The speed of sound equation is velocity is equal to wavelength times frequency. And we use this mathematically as V is equal to this Wavelength symbol is called lambda times F. V is the speed of sound. It'll be measured in meters per second. Wavelength, or lambda, is going to be measured in meters. And frequency is going to be measured in inverse seconds or hertz. The first question we're going to go over is, what is the wavelength of a sound wave in the air if its frequency is 100 hertz? Note the speed of sound in the air is 340 meters per second. Now, the first step whenever you're solving any type of problem is to find the knowns. Knowns are anything which is a term, it's a number with units behind it. In this case, we are going to be finding things in our equation. And the knowns are the 100 hertz and the 340 meters per second. Please note, it's a number with units behind it. Then, after we've identified them, we need to identify what they are. Since that's hertz, that's a frequency, and since that's meters per second, that's the velocity. Now, because of that, we can put it into our equation. Now, our equation is velocity is equal to wavelength times frequency. Second step is we're going to put in all of our knowns. So in the case of velocity, 340 meters per second, we're going to take the velocity part of our equation. 340 meters per second is just V. In place of the V, I put the number, is equal to, we don't know wavelength, so I'm going to keep that lambda symbol right there. And the frequency is 100 hertz. And now all we have to do is simplify it. And here is the equation. Now we need to solve the equation. In order to solve the equation, we're going to have to treat it like a math problem. In a math problem, you want to get all the numbers on one side and the letters on the other. So let's go ahead and clear this out and rewrite it neatly. 340 meters per second is equal to lambda times 100 hertz. Now our letter in this case is lambda. See how we have our 340 meters per second on one side, the equal sign, and then on the right side, we have lambda times 100 hertz. Now to separate things, we always do the opposite to them. Since this is being multiplied, lambda times 100 hertz, we're going to divide both sides. And we're going to divide both sides by 100 hertz. Anything divided by itself becomes 1. So that's going to cancel itself out because lambda times 1 is 1. 100 hertz divided by 100 hertz cancels. 340 divided by 100 is 3.4. Now, you don't need to know this, but inverse seconds and hertz cancel each other out. So that leaves us with meters. So our answer is the wavelength is 3.4 meters. And here's the long form where we divide it out and gives the answer. Now let's do another one. What is the speed of sound through a metal pipe if the frequency is 4,000 hertz and the wavelength is 0.2 meters? Step 1. If we're going to solve this, we got to find our knowns. What are our knowns? First known, 4,000 hertz. Second known, 0.2 meters. Now, what are our knowns? Hertz, if you remember, is our frequency. And 0.2 meters, that's our wavelength. Now that we have our knowns, we need our formula. The speed of sound formula is going to be velocity is equal to wavelength times frequency. Third step, put the terms, the knowns, in the different parts of the equation. Velocity is equal to, we don't have anything for velocity, wavelength. Wavelength is 0.2 meters. And frequency is 4,000 hertz. All we do is we multiply these two together. Velocity is equal to 0.2 times 4,000. See, there's nothing attached to our v, so all we have to do is just multiply them together. So 0.2 times 4,000 is 800 meters per second, and that's our answer. That's it. Now I want you to do one. What is the speed of sound through salt water if the frequency is 800 hertz and the wavelength is 3 meters? Okay, step one. Find knowns. What's the speed of sound? Frequency is 800. Oh, there's one of them, 800 hertz. And the wavelength is 3 meters. Frequency, wavelength. Step two, our formula. Write in V equals lambda times frequency. Step three, fill in our knowns. We don't have anything for speed, so we put the V in. Our wavelength is 3 meters, and our frequency is 800 hertz. 3 times 800 is 2,400 meters per second. That's it. Let's do another one. What is the speed of sound in the air if the wavelength is 10 meters? Note the speed of sound in the air is 340 meters a second. Okay. Step one, find our knowns. We've got a wavelength of 10 meters, and we have a speed of sound of 340 meters a second. Since that's in meters, this is my wavelength, and that's meters per second. That's my speed or my velocity. Step two, write our equation. Velocity is equal to wavelength times frequency. Step three, put in our knowns. We have V is 340 meters a second is equal to, our wavelength is 10 meters, and we don't know what frequency is. Looking at our equation, the 10 meters is being multiplied against frequency. That's our unknown, and 340 is all by itself. So since this is being multiplied, we divide. And that gives us 34 hertz of frequency. It's easy as that, folks. If you have any questions, here's our email.